Oh, it's from
Okay,
10.
Achtung.
We have a lot of time. You can go to the bathroom if you want to.
5 seconds. Whew.
Deep breath. Hello and welcome back, everyone, to this ending keynote of the conference. I'm here with Jonas Meyer, Thomas Endres, and Martin Förtsch. Förtsch, sorry. They're going to give us a short history lesson in deepfakes, which is a kind of new topic, right? And they're also gonna give us some introduction to cybersecurity regarding deepfakes. So, Martin, are you ready to end this conference in a spectacular way?
Yes, we are ready.
Great. So, audience, you can fire off any questions in the chat or in the QA tab, and we will try to have a short Q&A at the end. Otherwise, guys, take it away. The stage is yours.
Yeah, thank you. Ladies and gentlemen, dear
Okay, so I guess we dropped the presenters. Let's see if we can find them again. Sorry for the little mishap. Sorry for the delay. I'll see if I can have them back.
Yeah. Hi there.
Hello, welcome back. We've missed you guys.
Yeah,
Where were
we've
you?
been kicked for literally no reasons. We're gonna start sharing our screen again, and then we shall just continue.
Thank you. This is the first time this has happened to me, but I've heard of it happening in other tracks. So where were you?
Okay, shall we try it again?
Yes, from the top, please.
Oh, okay.
Yeah.
Whoa, okay, let's try it again. Ladies and gentlemen, dear audience of the Dev Days Europe. Today, we want to watch a short video we created with the German television channel ZDF, together with Professor Dr. Harald Lesch, who is a very famous scientist in Germany and in German television. Let's have a look.
Guten Abend zusammen. Willkommen bei Lesch Kosmos. Unser Thema heute Deepfakes, eine Technologie, mit der man praktisch jeden alles sagen lassen kann, und zwar in Echtzeit.
Das klappt ja wunderbar. Da kann ja, mit dieser Technik kann ja jeder eine Wissenschaftssendung moderieren, sogar du.
Ich und eine Wissenschaftssendung, was für eine absurde Idee. Aber wenn meine Stimme da nicht wäre, dann könnte man mich wirklich für dich halten. Und überleg mal, wenn man das so anders einsetzt, dann kann man damit ja eine völlig neue Dimension von Fake News schaffen.
Und das macht mir echt Sorgen. Die Möglichkeiten zu manipulieren sind damit ja schier unendlich.
Ja, man könnte zum Beispiel irgendeiner Politikerin oder einem Politiker irgendwas in den Mund legen, also was ganz Fieses. Und eine andere Regierung nimmt das dann ernst und drückt vielleicht auf den roten Knopf.
Wie so oft waren andere schneller als du und haben genau das gemacht.
Yeah, so they actually did it. They made a deepfake, just as Harald Lesch said. So when we were filming this last summer, we were never expecting that this would happen so quickly, at least. And I'm not sure if you've seen this deepfake. We certainly have, and we hate it. We hate the reason why it was made. We hate the context that it was made in. We just hate everything about it. But it's just such an important example of a deepfake going viral, doing weird stuff that we could just not let it out of this presentation. So yeah, some of you might have seen it, and some of you might have thought to themselves, well, this looks a bit odd. This looks a bit fake. Well, the reason is it's a deepfake of Zelensky, well, basically saying weird stuff in the last couple of weeks. And yeah, that's exactly why we're standing here today, because those people who recognize this as a deepfake, well, they knew that deepfakes existed. And the reason, well, the reason why we're standing here today is actually not our idea. We take the same take as Carl Bergström, who says, when a new technology like this comes along, the most dangerous period is when the technology is out there, but the public isn't aware of it. That's when it can be used most effectively. And just like this video, we want to, is not going to be effective if we talk about it. We want to tell you today about deepfakes, tell you everything about it, how they're made, how we progressed on them, how you can avoid them, how you can spot them, so that you shall not run into this trap. So after this very hard-hitting introduction, a more light-hearted introduction to ourselves, starting with Thomas.
So, hello everybody, my name is Thomas Endres. I studied computer sciences, and after my studies I joined TNG. I'm now one of the managing partners at TNG, and together with Martin in a galaxy far away and a long time ago, we created the innovation hacking team, and since then we've been working on innovative prototypes, starting from robotics and gesture control to AR, VR, and more recently AI. So Martin, take it away.
Yeah, hi. So my name is Martin Förtsch. I've studied computer sciences as well, and I'm working for TNG since 16 years. And within the last years, Jonas started in our innovation hacking team.
Yeah, so my name's Jonas. I'm a senior consultant. I studied games engineering, actually, and then I thought I might as well do something useful. Now I'm doing deepfakes, so that worked kind of out. And that's pretty much everything you have to know about me. So, Martin, why don't you tell us a little bit about the history of deepfakes?
Yeah, why not? Let's have a look. So, deepfakes. How old is this stuff? Let's go back into in the year 2017. The first news articles, TNG created the first real-time deepfakes in 2019. There was much press coverage in the German press. And later on, we made some improvements with it, which, resulted in much more media coverage. So let's have a nearer look on that. Back in autumn 2017, there was a person named Deepfaker, and he published some videos on Reddit. Okay, so which videos? So let's say he moved his famous actresses to another movie genre. So this is the reason why there were some headlines like on Wise Motherboard, AI-assisted fake porn is here, and we are all... This was in spring 2018, by the way. 2018, Deep Face Lab was published on GitHub. So Deep Face Lab is the first software which was available to the public to create deepfakes. What were the main features? With Deep Face Lab, you were able to do face replacement. This was a task which was made possible via post-video processing. So you needed a video which you want to fake, and you needed a video of a person where you can see the face of this person, which you want to fake into the original video, which is a very time-consuming task, by the way. It has a very wide distribution. So people are saying that 95% plus of all generated deepfake videos are realized with Deep Face Lab. And it's, as I already told you, open source. Professor Howley, by the way, he said in 2019, there will be perfectly real deepfakes. They will arrive in 6 months to, a year. And we from the innovation hacking team, we thought, those deepfakes, they are not real time. Let's think about that. So our motivation was in 2019, are we able to make them real time? We also thought about why not just replacing the whole head instead of just the face. And the idea was that it should work with any source actor. So we just stand in front of a camera and your head gets completely replaced with another one. Also, if your face is not trained in the deep neural network. So it just should work out of the box. And the idea was that we want to create awareness. This is here, obviously. Okay, so let's have a look to the agenda. Deepfakes in a nutshell. Then we want to talk about the first real-time implementation we did. Then we tell you how we improved all the stuff and where the problems were. And then the cybersecurity part is about video calls with deepfakes. We did an experiment with a German television channel, then audio deepfakes, and last but not least, a conclusion. So Thomas, I think it's your turn right now. How can you create deepfakes?
Yeah, first you have to really understand how a deepfakes works in its innermost workings, and this is something we're going to talk about next. And at the heart of each deepfake, there is a neural network which is called autoencoder. An autoencoder is a so-called bottleneck network, and it is called bottleneck because, yeah, in the middle we have some kind of compressed space where the image is not is just represented in a compressed way, and this is the so-called latent space representation. So on the left side we have the original image, on the right side we get exactly the same image, and in the middle we have the compressed latent space representation. And between those different areas, first we have an encoder which basically breaks down the image and puts it into this latent space representation. And then on the other side, we have the decoder, which does exactly the opposite. So it takes the latent space representation and puts that back into the original image. And this is fine as long as the network is, of course, trained. But first, we really need to train it, because at the beginning, if you just take an uninitialized neural network, it will just create random noise from that. So we give it just a few samples of faces in this example. And then we can basically, train it, get given the input image, we get the same output image again. And when it is trained, then we can then have a latent space representation, which basically consists of things like are the eyes open, is the mouth open, and is the person smiling, things like that. So this will end up in the latent space representation. In order to do this, we have to do the training part. And here you can see a bit of how things are trained in the neural network. So we are taking a pixel-wise comparison from the original image and comparing that to the resulting image. And then we can use that as a loss function for the neural network. And with that, we will then create a perfect autoencoder, which, given an input image from Harald Lesch, will recreate that image again, which is basically pretty boring. But the magic happens if you just take two of these autoencoders. So now we have one autoencoder for Dirk Steffens and one autoencoder for Harald Lesch. And we now take the face that we get from Harald Lesch, put that into, use the encoder and put that into the latent space representation. And then we have the facial expressions from Harald Lesch. And now we do the trick and use the opposite encoder. So we are now using the decoder. So we are now using the decoder from Dirk Steffens. And given that, we will recreate the face of Dirk Steffens, but with the facial expression from Harald Lesch, from the original image. And then we have our deepfake, actually. So this is how a deepfake works. And now let's have a look at the real-type deepfakes implementation, our first one. So this is Deepfakes 2.0. What we tried to do with Deepfakes 2.0 was a whole head replacement in real time. And for that, we had to do some steps, actually. First of all, we had to capture the frame from the camera. Pretty easy. Then we had to do something, face detection. So so to just see in which area the face is located. Then we could do something that is called face segmentation. So in this case, we are now extracting every pixel that belongs to the face and discriminating that from every pixel that doesn't belong to the face. And when we have that, we can then eliminate the original face because we do not need it anymore. We will replace that with a different face image. And this different face image then has to be generated from the segmented face, and then we can put that on top of the resulting image. And as you can see here, all these steps are executed partly on the CPU, partly on the GPU. We have lots of context switches, But nevertheless, this implementation was already able to do deepfakes in real time, and we'll get to the optimization a little bit later. But for now, let's have a look at the concrete detailed steps. First of all, we'll have to do our face detection. And for this, we are using a computer vision library called OpenCV and just loading in a neural network which detects our faces. So let's have a look at the demo. Here you can see now faces are correctly detected. Martin and Jonas are just fooling a little bit around. And as you can see, multiple faces at the same time are no problem at all. Also, if you just turn your head around, this will also work. If you hold your hand in front of your head, it will still work. And it will define roughly double the size of my face. And this is the area where we can now look for the pixels that belong to the face. So let's have a look at the next step. And this is the face segmentation. And for this, we really have to look for every pixel which belongs not only to the face, but also to the whole head. And with that, we can now colorize the faces, and every part that belongs to the head is then turned blue. So I look a bit smurfish now, Martin as well. Or yeah, and as you can see, again, we have a real-time implementation. Everything works in real time. It works not perfectly, but okay-ish if I turn my head like that. It also works if I have my hand in front of my head. So this kind of also works. As I already said, it is not perfect, but it is good enough for our case. For this, we did not have any predefined neural networks which we could use like we had with face detection, but we had to create our own neural network. And this was a bit tricky because normally you need lots and lots of training data, so labeled data, so lots of faces that already contain the information where the head is. And we did not have that. So we had to do something which is called transfer learning. And let's have a look at that. So first of all, we'll take a pre-trained neural network, a fast one, MobileNet, which is also able to be executed on mobile devices. And this is actually a network that is not there for segmentation. It is there for classification. So it can tell whether an image of a cat contains a cat or a dog or something else. But it cannot do segmentation. So what we did then is just throw away the last layers, which are there for the classification part. And instead of that, we are using another neural network and just putting that on top of the first layers that we get from MobileNet. And this is a so-called UNet, which is also a fast neural network, but this one can now be used for segmentation. And when we now train this complete neural network consisting of a pre-trained MobileNet and an untrained UNet, we just need, so the net basically already knows a little bit about the world. So it knows what a cat is, what a dog is, and things like that, and probably also where it can find them. So the only thing we need to train now is what it has to do, so the concrete segmentation task. And for this, we only need a few thousand images, but still we need a few thousand images. And therefore, we need a good data set. Fortunately, there are good data sets out there. And the one that we used in this concrete example is Celeb A Mask HQ. So this is a celebrity photo data set, and it consists of two parts. First of all, of course, the photo of the celebrity. And second, we also have a segmentation. And as you can see, this is a hand segmented data set. So there was one guy who was really doing all this by himself, by hand, and just extracting the area of the face, and then also hair, ears, nose, things like that. So every single part of the image is segmented with a different color. And now we just need to take everything that belongs to the head and take this and use this as a training input for our neural network. So this is basically how the segmentation works. Once we have the segmentation, we can now do a third step, which is called Inpainting. Inpainting is something that you probably have already heard of when it comes to photo restoration. So if you ever wanted to repair these old photos where there are scratches on them. This is exactly what happens here. So you take a mask, so you mask everything that should be repaired, and then normally if you have a classical computer vision approach, the pixels from the outside flow into this area, and then they fill this area. And this works pretty well. And we used it for not just scratches on the image, but for our complete face. So it completely replaces our face. And as you can see here, yeah, my face is pretty much gone. Same for Martin, same for Jonas.
Oh my
so
God.
Also, again, it works in real time. So this is quite good. And we just had to use the OpenCV, also our computer vision library algorithm here again, and got this to work pretty neatly. And now that this is all done, this was all the preparation that was needed, and now we need to do the step that is really important for this, and this is the autoencoder. Jonas.
Yeah, we've pretty much talked about everything but the very important part, which is the neural network that does the deepfake. And so the problem at hand is we want to run this deepfake that is a post-processing step in real time and for every single person that stands in front of the camera. So our solution to this was, we used to have 2 decoders, one for each person that we have in the deepfake, but now we have N decoders. So we can train a Harald Lesch, a Dirk Steffens, a Drachenlord, and even a Putin. We'll have to admit the example here didn't age too well. We made the slide set like half a year ago. And now we can train all these faces at once. This is the neat side effect that we don't have to train each face that we want to have individually, but we can train them in bulk. And it also has the benefit that the encoder learns to generalize faces pretty well, which means that whichever face you put in front of the camera, the encoder will able to understand it, break it down into the latent space, and thus the deepfake will work. So given this beautiful architecture idea here, we started implementing and started training our first models. And well, it didn't work out too well in the beginning. We got some strange results. And well, here you can see, in case it wasn't spooky enough that we just disappeared, here's Martin with an eye on his forehead. We also got stuff like Picasso paintings and very fitting Trump with a mouth on his forehead. And then also some weird things like man, bear, pig, and even alien Obama for all of you conspiracy theorists out there. And so we noticed, well, with all the changes that we had made so far, the training objective of learning how to recreate a face just kind of got way, way harder, and maybe too hard for the neural network to learn on its own. And therefore, we decided, well, we kind of need to give it a little bit of help. And that help, we wanted to give it in the form of so-called GAN training. Well, GAN training, you may ask, what is that? That actually stands for Generative Adversarial Networks. So what that means basically is we have a fight between a generator and a discriminator, and we want to invite you to join this fight right now.
Fight.
Yes, it pays off now that you stayed for the last closing keynote, because we're going to have a live fight here on show for you. Obviously, we're not going to fight in real because we're computer guys. So we're just going to fight verbally. And for that, we're going to distribute different roles. We're going to do like an offline role play game. And we need 2 roles. We need a generator and a discriminator. And well, Martin looks good at generating things. He has 2 kids, so that works out. And then also we have Thomas, and for no particular reason, he's going to be the discriminator.
Yeah,
and
a role I can
Managing
familiarize.
Yeah, exactly. He's CEO, by the way. So, and then I'm going to be the referee, and the objective is going to be, well, Thomas is going to be the generator. So the autoencoder that generates, no, Martin is going to be the generator, the autoencoder that generates the deepfakes. And Thomas is going to be his opponent and has to guess whether this generated face from Martin is real or fake. So let's start with round 1.
Round 1.
So what you see right here, what you see right here on the left, Martin, is your input, right? You see it here. This is a face, right?
Yeah.
Well, Martin, of course, doesn't know because he's a newly initialized neural network. He has never seen anything. So your task is basically to replicate this face and make it facey, make it face-like.
Okay.
Pretty easy task, right?
Or bias.
Okay. Great
Okay.
stuff. Okay, so just go ahead, just reproduce this face that you have right here. You can use
Okay.
this mouse.
Okay.
And just take your time. Let us know when you're done.
Okay. So I'm a completely newly initialized, unweighted, deep neural network, and I don't know what a face is. I don't know where to start. So typically, I just would start with some kind of maybe noise or something like that. Yeah. So I'm finished here.
Are you for real?
Yeah.
Okay. Yeah, whatever. That's gonna be good enough. Okay. We're gonna move on. Now it's Thomas' turn. Thomas.
Yeah.
Okay, here you have two images, right? Like one is clearly a face and the other one is
What is
something...
an image?
Yeah, whatever. So which one is real and which one is not, is fake?
I don't know anything. I have never seen anything before, so I'm just gonna guess. I think. Okay. So that's a CEO way of doing things. And let's say the right one.
Let's see if that is correct. The right one, and it is the right one. That is the real one. You were correct.
Yes.
Good job, Thomas. What did you learn?
So I think there's somehow some connected lines or something like that. So this is what I saw, and I think that might be a clue. Huh?
Okay. Martin, did you listen to what Thomas just said?
Yes.
Do you think that might help you in the creation of whatever?
Yeah, maybe.
Okay, so then let's move on to
Round 2. Fight!
Okay, Martin,
So-
same thing again. You have your input here.
Yeah.
Now please draw something that looks like a face.
Okay. So connected lines was something I've heard. So I would, but why not trying something like this? Yeah. Okay. I'm finished. Here, please.
Well, yeah, okay. I guess we'll just take it. Thomas, it's your turn once again. Which one is the real face and which one is a fake?
So let's have a look. So connected lines are in both of them, but still, what I remember from the last image was that there was some color in it, and so I'm just gonna guess that the left one is the correct one because it has some color again, and the right one does not. So let's go with the left one.
The left one. Okay. And that is correct. And now, for the sake of everyone's time, since we just have 1 hour, we're going to skip ahead a couple of 100,000 iterations, which is going to be a couple of weeks of training. And Martin is going to
Round 3. Fight!
is going to get better and better at drawing. So, Martin, give us your best shot at drawing. Your input drawing.
Oh my
a
god.
Martin.
Okay, so I'm trained for 100,000 iterations right now. And now I have the right tools. My weights and biases, there are really
Yeah.
tuned.
Less talking, more
Yeah.
drawing.
Okay. 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 Let's try it.
Head.
Yeah. Head. Okay. Mm-hmm.
Jesus.
Mm-hmm. Okay. Okay. Let's try this.
Jesus Christ.
So I learned a lot. So obviously I need some kind of a eyes, and I think the mouth is still missing. And yeah, I would say that's it. This
Okay.
is
Wow.
perfect, I think.
Wow, like you've really improved, Martin. So, Thomas, give it a shot. What do you think? Which one is real? Which one is fake?
Oh Jesus Christ! Okay, I think we're good enough so that the right one looks close enough to the left one. I think we can just skip from here.
Yeah, you're absolutely right, because you can't tell the difference.
Yeah,
right? They're just too close.
Absolutely, it's the same horrible face on the left and on the right, so it's fine.
Yeah, and actually, for you people at home, it's the left one that is the real one. So what we just larped here for you is actually a very boring process that happens on the GPU many times a second. So on one hand, we have this data set of real faces, and we have the generated faces from our generator, which is the autoencoder in our case. And the discriminator is trained to distinguish between real and fake. Depending on its output, it will get like some kind of loss. And the generator will be trained on generating faces that look real to the discriminator. And this way, we have like the cyclic dependency of both of our generators and discriminators, which is going to start from nothing and then generate perfectly photorealistic deepfakes that hopefully don't have eyes in their foreheads anymore. And we want to see if that is actually the case and start a live demo of the first deepfake that we did. And you can see, well, it's still me, but with a weird haircut. Thomas, let's give us your face and see how that looks. Well, move a little bit closer to the camera, please. Yeah, and you can see it. Well, it definitely changes his face. We can also change different faces. Now you can see Thomas has a beard and looks a little bit more like, like he smells funny and plays the guitar. Now Thomas has turned into a woman, and so on and so on. And we don't have any eyes on our foreheads anymore.
Which is a good thing.
Which is a good thing. And you might be able to tell, well, it's not quite the best thing ever, but we're going to talk a little bit more about what we're going to do about this later on. All right, Martin. So we created our first deepfakes, and we went public with them, didn't we?
Yeah, yes, of course. As we already told you, the idea was that when we make progress, if we are able to create real-time deepfakes, we wanted to create awareness. So media just published headlines like German scientists made real-time deepfakes possible, and different German television channels just contacted us. They wanted to make news about that. And of course, what we also did, giving talks, not only on IT conferences, also some conferences where journalists or politicians were there. Yeah, there was a computer science, a science slam, and there were people from the German television channel ZDF, and they asked us, hey, Lesch's Cosmos, Professor Dr. Robert Lesch, we want to make an issue about deepfakes. Can you help us? This was in 2019. And we said, yeah, perfect. That's awesome. But then Corona came, and we had much time to improve our deepfakes. But why? Let's have a look to the very first real-time deepfakes. Worldwide, you could say, a video of that. So this is at our conference Big Tech Day. And here I filmed myself, as Barack Obama. And let's have a newer look on that. When I'm smiling, it looks somehow distorted. Also, if you have a nearer look onto the face, there are skin details somehow missing. It looks smeared or something like that. And also, if you have a look to the head and the surroundings, it looks not that good. An advantage is that Barack Obama has also a bald like me. And let's have a look if there is no bald. Like for this guy, you recognize him, obviously. And here we have the hair of Donald Trump. He has full hair, and this gets projected on my bald. This looks not realistic. Also, when I'm moving the eyes and everything, and it's not cool enough. So for the hair, we thought we can do the hair trick. Means, why, if you want to appear as Albert Einstein, for example, why not wearing a toupee and helping the deep neural network to create a better Albert Einstein in this case? But you can see it was not really good. And one of the reasons, of course, is that there is not much video material available of Einstein. And now we want to start with the agenda point, pushing deepfakes to the limit. And this is Jonas' part.
Yeah, so we wanted to improve on the deepfakes that we already had, but we had kind of noticed during the development of the first prototype, which was written completely in Keras and NumPy, Keras is not going to be the perfect tool for what we want to do anymore. It simply is too easy, and we're kind of working against the API. But gladly for us, TensorFlow 2 came around the corner. And right in the summer of 2019, when we started reworking the deepfakes. And the cool thing about TensorFlow 2 is, well, it's in a loving relationship with Keras, which basically means TensorFlow and Keras have now turned into this very cringy couple that only shows up at parties together and then that spend time all the time together. So as you also can see in this visualization here, Keras is going to be more of like the high-level API that allows you to do like the very easy stuff simply and quickly. And TensorFlow, as you can see, it's more down there. It's the low-level API for doing all the more complex stuff. For example, if you're programming GANs, which is perfect for us, because then we can use all the neural networks, all the encoders, decoders, and discriminators that we wrote in Keras anyways, we can just reuse them. And then write, for example, our training pipeline optimizes TensorBoard logs and the data loader in TensorFlow and do all the very complex stuff in there. And then we have the losses there kind of in the middle. We're using Keras losses, but adding them together in TensorFlow. So speaking of data loader, one neat thing in TensorFlow 2 is, you can have use the TF data pipeline to streamline your data loading, which is going to load your data off the disk in a multiprocessed fashion, which means basically it runs insanely fast and you can use large data sets, which was very helpful for us because larger data sets means better deepfakes. And what we finally ended up with was like this modular training pipeline that allowed us to, play around with different configurations of training parameters, weights, loss functions, and even different purpose discriminators. And this allowed us to improve on the quality of the deepfake significantly, as you can see in this little video here. Here you can see we did a funny little deepfake of Donald Trump once again. On the left, you see the input. On the very right, you see the new deepfake. And for comparison in the middle, you see our old real-time deepfakes. And you see, it looks quite better. We have quite a lot more details. The teeth, for example, and the skin. But there's still some things going on. Like there's a weird warp to the face, for example. And that was actually a problem that we could not really solve in here. And so we had a deeper look in what is actually going on here. And we figured, we have distortions in the face. And those are probably due to the fact that we do the face detection and just as a bounding box, and the face is not always aligned in this bounding box. It's also not always centered. And then as a last thing that we saw, with our old inference pipeline, we still have quite improvable performance. And you can see this here in the short clip from the Fujitsu World Forum 2019, where, not sure if it comes through in the stream, but we had like something like 1 to 2 cinematic frames per second. So it was not the fastest thing ever. So one thing was still missing. We had TensorFlow 2, but we still needed something that could align the faces for us so that we don't get the warp anymore. And that little something is MediaPipe. Thomas.
Yeah. In 2021, when everyone was bored because of Corona, we found a new library, and this is the MediaPipe library. And MediaPipe is basically a library for streaming images where you can use different algorithms to process these images. It is a ready-to-use solution, so you can use it right away. It can be deployed pretty much everywhere, so in the browser with JavaScript or on your workstation with Python or pretty much everywhere else, also on your mobile phone. It works quite well, and it has an end-to-end acceleration, which makes it really fast. So this was also very important for us. And the last thing is it is free and open source, so we could also use it right away. And what we definitely needed was something that could, as Jonas said, align the face. And here we found something, and this is the so-called face mesh. Face mesh, as you can see, just puts landmarks on your face. And this is incredible since it is done in real time, is really fast, and it will also do all the alignment stuff that was not perfect in the last implementation. So face mesh is based on the Blaze face detection. So if you just scan the QR code on the right, you will have a more detailed explanation of how Blaze face works. And So this is the inner workings of it. And once you have done all this face detection, then it will also fit a model onto your face. And this is what the model looks like. It has 468 landmark points. And this is the surface of your face. So it will work way better than most of the other landmark detectors that we have on the market right now. And with that, we can then also not only construct a 2D face, like in this example, but we can also reconstruct the 3D surface of the face, which is pretty cool, and which also helps us a little bit in finding the correct location of the face. Which is also, so there are some features which are also cool for face mesh, and one of them is being the temporal consistency. So you can even hold your hand in front of your head, and it will still fit the face pretty much correctly. And this will also help for the robustness of our deepfakes. And another thing that will help us is that it can work with pretty much every face within the whole world. It was trained on an ethnically diverse data set. So whoever sits in front of the camera will be detected correctly, and the face mesh will be applied correctly. So without further ado, let's have a demo here. And we're going to just skip the old process and start a new one. And as you can see now, here is the face, and you can see the 468 landmark points on my face, and this will also work for pretty much every other person here as well. So let's have a closer look to the inference workflow of our Deepfakes 2.1.
Yeah, so now that we have the last missing piece, we can start over with the completely new inference pipeline, starting off once again with the frame that we grabbed from the camera. That's going to be on the CPU. Once again, nothing changed here. But now we have media pipe face mesh. That's going to be our face detector. It's going to run on the CPU, but still it's extremely fast. It's like 4 milliseconds that we need for that. And once we have the face and we can crop out the face that we need, we can then just push it onto the GPUs. You're using TensorFlow, and we do the face segmentation, the inpainting, and the generation of the new face, as well as fitting it back into the original image, all in one pipeline, all on the GPU. And yeah, this works extremely fast, and we're going to have a look at, well, yet another example that didn't age too well. So here we have, what's his name? Harald Lesch again, deepfaking him to, well, Vladimir Putin. And we, in the middle, you can see we apply the face mesh. It works quite well. And now with the final deepfake step, with the alignment that we have now, we don't get this weird face warp that we had before. Well, we have to admit, in this case, they both kind of have the same shape of the face. But nonetheless, it improved on this problem quite a lot. And talk is cheap, videos are cheap, but real-time demos are not. And that's why we want to show you a deepfake demo if it doesn't crash, and I really hope it doesn't. No, it looks about right. It's just going to take a couple of seconds to fire up because we forgot to start the demo earlier. And bippity boopity, perfect. Now I'm a deepfake, and you can see I can't really open my eyes. Well, I can if I look into the camera for once. Well, now I'm some German TV guy, and we're going to find out who that is later. But I can also change my face. Now I'm myself with a different hairstyle and pretty horrible lighting. And we can also swap to Harald Lesch and talk to you live. We can also be this bold guy, for example. And we're going to find out who exactly this guy is right in the next topic. Thomas. Martin, whatever.
Yeah, this brings us to the cybersecurity part of our keynote today, video calls with deepfakes. So let's move on. So it was, oh, one moment, sorry. Video calls with deepfakes. Here we are. Yeah, Pro7, German television channel with Galileo. And they wanted to make some news about deepfakes, but they thought, why not doing an experiment with it? So the idea was the following. Here we see two guys. So on the left, this is Harro Füllgrabe, and on the right, Matthias Fiedler. So now the experiment was Harro Füllgrabe will be sitting in front of a camera in a Zoom meeting. The video stream goes into our real-time deepfake software, and inside the Zoom meeting, he will appear as Matthias Fiedler, the bald guy here in this case. And the idea was calling a friend. And now let's have a look what happens here.
Ruhig. Das Live-Deepfake-Experiment beginnt. Fliegt Harro, hier als Matthias, auf?
Hallo, Richard! Du glaubst gar nicht, was hier alles los ist. Die Leitung stimmt nicht, dann geht das in die Hose und das geht in die Hose und das klappt nicht.
Die erste Hürde ist geschafft. Der Chatpartner schöpft keinen Verdacht. Dann gehen wir einen Schritt weiter. Harro alias Matthias schickt ihm eine Datei. Sein Gegenüber öffnet das Dokument ohne zu zögern. Gefährlich. Im Fall eines echten Betrugs könnte es sich um einen Virus handeln. Richard tappt in die Falle.
Hast du es bekommen? Jetzt habe ich es bekommen.
Funktioniert der Live-Deepfake sogar so gut, dass wir den Chatpartner dazu bringen, dem Spendenaufruf zu folgen und Geld zu überweisen?
The answer, transferring money here in this case, is yes, you will. So, what are the attack vectors when it comes to deepfakes in times of Corona, of home office, being in the video conference? It's sometimes much more harder to say if there is a deepfake sitting in the meeting. So the attack vectors are different. So you can use it for phishing scams, for data breaches, celebrity brawn, reputation smearing, whatever. There are a lot of more. Election manipulation, social engineering, of course, propaganda, identity theft, financial fraud, and so on and so on. And if you think this is not true, let's have a look to this headline. A German woman thought she is in love with Vin Diesel and sent her 5,000 pounds, British pounds, in an online scam. Now, the German television channel Pro7 made another experiment. Now, Harro Füllgrabe will make contact with the parents of Matthias Fiedler. Let's have a look what happens here.
Wieder wird Kollege Harro als Matthias in den Videochat gehen. Wird es auch diesmal klappen?
Hey, Papi!
Mannes,
Ein Idiot!
bist du schick, Junge.
Aber Schätzchen, was ist denn mit den Kindern los?
Denen geht's super. Ich bin halt gerade bei der Arbeit, aber denen geht's gut. Alles perfekt.
In den ersten 2 Minuten merkt keiner etwas, aber dann wird Matthias Mutter plötzlich stutzig.
Dein Gesicht ist so fremd.
Sie merkt, dass hier etwas nicht stimmt.
Seht ihr mich doppelt?
Bist du das?
Das bin ich. Du hast ja erkannt, dass ich das nicht bin, oder?
Ja, du hast ganz fremd aus. Ich sehe durchs Telefon, wie es dir geht.
Danke, bis bald. Ciao. Liebe Grüße.
Ja, ich hab's ja geahnt. Meine Mutter, wie sie schon sagte, die erkennt über den Bildschirm, ob ich gesund bin oder krank. Und die hat natürlich auch sofort gemerkt, dass ich das nicht bin. Also ihr Deepfaker, ihr könnt reinlegen, wen ihr wollt, aber nehmt nicht die Eltern. Liebe Schaum.
Ja, Papi, alles schick. Yeah, suspicious behavior. Probably the Matthias Fiedler wouldn't do things like that. But Thomas, I think this is your first slide.
Yeah, this is my slide actually. So you cannot fool everybody. So basically the parents in this case really noticed the suspicious behavior. And this is also the first line of defense that you can apply whenever you want to detect if you are talking to a deepfake actually. So there are also some technical things that you can consider. So for example, as we already told you a few slides ago, low level of skin detail might be a sign. Also unusual distortions, which might happen especially in the face. It might not be perfect. So around the head, there might be some artifacts, or also if we have bad training material, lack of emotion might occur. And there are also some things that look unnatural. So eyes, hair, and teeth are normally the places where you should look. And also eye movement or facial expression might not be perfect or might not be what you are expecting in this situation. And also coloring might be a bit different than you might be familiar with. And all these things are technical, but they are just things that might change in the future because the technology is improving, and in future deepfake implementations, this might not be true anymore. What you can rely on, however, is, of course, the suspicious behavior. And one thing that is really hard to deepfake at the moment, and this is inconsistent noise or audio, because as we will find out in a second, audio is still very hard to deepfake. Let's have a look at that.
Yeah, so audio deepfakes. We talked everything about video deepfakes in real time, video deepfakes, this, that, blah. Now let's talk about audio deepfakes. So we're going to have a first look at how Hollywood thinks that audio deepfakes would work right now.
John, it's late. Honey, I was beginning to worry about you. If you hurry home, we can sit down and have dinner together. I'm making beef stew.
Something's wrong. She's never this nice.
John? John, honey, it's late. Please don't make me worry.
Can we be there?
Honey, are you okay?
I'm right here. I'm fine.
Are you sure? Are you sure you're all right?
What's the dog's name?
Max. Hey, Janelle. What's wrong with Wolfie? I can hear him barking. Is he okay?
Wolfie's fine, honey. Wolfie's just fine. What are you?
Your foster parents are dead.
So here we have the dystopian Hollywood fantasy of how audio deepfakes would work. We have the audio deepfakes on both sides, both Arnold Schwarzenegger being the little boy, as well as the evil robots on the other side playing dead foster parents. So how does this look in reality, though? Well, something similar to an audio deepfake might be a text-to-speech algorithm, and there's quite a few of them. For example, Tacotron 2, which has been around since 2017, and what you can do with it is you can train it on basically whichever voice that you want, and we did so for Arnold Schwarzenegger. And we have a little game for you right now where we're going to show you some audio clips, and you have to, well, guess whether this is a real audio clip from Arnold Schwarzenegger or an audio deepfake. Let's start.
Positive thinking can be contagious.
Yeah, positive thinking can be contagious. You can hear it's very Austrian. Kind of hard to tell. Let's have a listen to it again.
Positive thinking can be contagious.
Yeah, so quite hard to tell. It sounds like Arnold Schwarzenegger for sure, but it's actually a fake. So this was a Tacotron that we trained on Arnold Schwarzenegger. It takes a couple of hours. You just need a couple of minutes of audio files for this, and it's easy. Let's have a look at another example.
The more you temper a sword, the stronger it becomes.
Once again, it sounds like Arnold. We have even the Austrian accent in there. Let's have another listen.
The more you temper a sword, the stronger it becomes.
Well, this one is actually a real one.
The more you temper a sword, the stronger it becomes.
Why the hell Arnold Schwarzenegger is wielding swords as the governor of California is out of the reach of this talk. But nonetheless, some of you might have said, well, I know Arnold Schwarzenegger in and out. This is going to be easy. We now have another example for you of a voice that you might not know. And let's give it a listen.
Dirty bomb. A nuclear weapon improvised from radioactive nuclear waste material and conventional explosives.
Well, this sounds quite real. However, it's a fake. So this is also a Tacotron 2 that has been trained on way more data for way longer and way better than Martin could ever do it. And also because you don't know the voice, it's really hard to tell what's real and what's not. And this is actually a reality in, when it comes to scams as well. There's a couple of headlines going over CEO fraud and somebody making phone calls and getting access to $243,000. And so you can definitely tell, well, audio deepfakes and soundboards and all of that is kind of out there, and it does work. However, in the case of live audio deepfakes, we're talking about text-to-speech algorithms so far. So we need the text, and we kind of also need, emotional states and all of that, and that just doesn't really work when translating speech to speech directly in real time. So this is something that we are still safe today. All right, so now we've seen everything from how deepfakes are made in a nutshell to real-time deepfakes to pushing deepfakes to the limit, video calls, pranking your friends, as well as audio deepfakes. So finally, time to come to a conclusion, Martin.
Yeah, it's time for a conclusion. So let's have a look to the evolution of deepfakes again. So it started back then in 2017 with Deep Face Lab, where only the face was possible to replace, and it was a non-real-time process. It took hours if you have potential hardware for that. 2019, TNG's first deepfake real-time implementation, where we replaced the whole head and so on. And let's have a look to the last 2 years. We improved everything, but also Deepface is evolving. So Deepface Live can now do live replacing the face, only the face, but not the head. So there is a lot of things going on. In 2019, we predicted that deepfakes will be used in the industry. And now, please guess which of those both videos here is generated with CGI and which one is realized based on deepfakes. 3, 2, 1, and we solve it. CGI is the upper video and the bottom video is created with deepfakes. And what is the difference? Yeah, of course, hundreds of thousands of dollars. CGI is a very complex process. It's very expensive. And for deepfakes, you just need hardware and many graphic cards. Yeah, so we predicted it will be used in the movie industry. And it happened, actually. The predictions of us came true. Lucasfilms hires the YouTuber who deepfaked Luke Skywalker into the Mandalorian, into Star Wars Mandalorian. Yeah, cool, isn't it? That's the good part. So we answered the highest voted question here in this case, I think. And another thing is that there is a new market, so you can license your face. Here you can see an advertisement. And who's this guy? It looks like Bruce Willis, but he isn't it. He just, sold his face, a license for his face, so that it can be used in this mobile phone company's advertisement. The good, but there is also the bad and the ugly. And this brings us, of course, to the video we began with. Deepfakes can be used for propaganda. They can be used for fake news. That's clear. And we think that we have to create awareness on that. And not only we, it's also your task. So hopefully you learned today something about deepfakes and what is possible today. And spread the word about that. Everybody should know what's possible so that they don't take the trap, that they don't get fooled. And with this, we want to start our Q&A session because that's it for the moment, ladies and gentlemen and dear audience. Okay, so
wow,
I think it's
great
time
presentation.
to answer questions.
Yeah, do you want me guys to read them?
Yeah, sure.
If you like.
You already answered the top voted question, right? What the purpose of this will be in the future. Or do you guys want to add anything else to that answer?
No.
No. Okay, for the next one. For what purpose are you doing deepfakes? Who are your investors and what does the investors want to achieve particularly? Maybe you do work for game industry or... Yeah, tell us about it.
So basically what we are doing is we are doing this in the context of our innovation hacking team. So the innovation hacking team was always concerned with innovating within new and exciting fields. So we are trying to push the limits of technology a bit further. And we did this in previous examples or in previous works where we, for example, used a style transfer AI to get to see the world from the eyes of an artist, but also in robotics and things like that. So we are doing this to learn for ourselves, to show other people what is possible with today's technology, and also to to become a bit more interesting. So to have some interesting projects which are maybe not our customer's project, but parts of it can be used within the realm of our customers. So for example, whereas we would never have a deep fake for our customer, parts of it can actually be used. So we used, for example, the segmentation algorithm for other projects as well, where we do a dynamic privacy mask, so that you can segment out the face from security camera footage and things like that. So for us, it's playing around with technology and showcasing this at different occasions and using parts of it for other projects as well.
Yeah. Spreading the word.
Great answer. So next question. How do we battle the use of deepfakes for ill intent? Interested in both technical and logistical implementation ideas.
Yeah, so about the technical ideas, well, there's a couple of deepfake detectors. Problem here is it's always a cat and mouse game, like, cat. So deepfake detectors will always just work for the deepfakes that are out there already. So if a new deepfakes come along, it will not work anymore. So I think the technical side of things is not really going to be the solution here. I think we have to start looking at it as some kind of Photoshop, where if you see some footage, if you see some videos, you might just think critically and be like, is this going to be real? Is this an actual thing? Or is this maybe a fake? So the only real way to tackle deepfakes, in my opinion at least, is to think critically and not take everything for 100% that you see out there on the internet, even if it's a video or even if it's a live Zoom call.
Great. Quick question. Will you use this for good or evil?
That's a great question. That's a great question. Well, we actually are a consulting company. We have a code of conduct, so we swore not to do evil things with it. Okay. And so everything that we do with this is just have fun, go out there, spread the word, show the world that stuff like this exists, have a technological advantage over people who might use it for ill intent. That's everything we want to do with it.
Yeah. And
last
also,
question for me.
So there are also these civilian use cases. So for example, if a TV studio or something like that came around and wanted to use our deepfakes in their production for an entertainment thing or something like that, we would definitely consider it. If someone came around to spread the fake news or something like that, we would definitely not do it.
Okay, last question. We'll have a quick answer for this one then. What's the current problem you're solving right now? And do you think developing a deepfake algorithm of a full body, not only face, is possible?
Yeah, so at this point, we've kind of tackled quite a few bottlenecks so far. Like we talked about how we got rid of NumPy and Keras and everything and have everything running in a single TensorFlow pipeline. The real issues that we're having right now is that, once again, media pipe face tracking is just not good enough, because it works quite well when you look straight into the camera, and even if you look like 45 degrees, but it breaks once you move further away from the camera. And we kind of also want to have a deepfake that works from behind. So for that reason, we're looking for some new solution for detecting the face and kind of tracking it as well. And then another thing is just simply the speed that kernels can be launched on the GPU. That is the other bottleneck. So we basically can't go any faster with the hardware that we have today.
Great. Thank you so much for a super inspiring and frightening presentation. It was lovely to have you here, and a great ending keynote. Thank you very much.
Thanks for having us.
Thanks for having us.
Thank you very much, and stay healthy.
Thanks. Yeah. So wrapping up this conference, these were all the talks of the second conference day. I hope you all had an amazing day full of inspiration and meaningful lessons. Once again, I want to say a special thanks to our sponsors, Rocket Software, Allegro, TechTree, Accenture, Andela, Oxylabs, For Finance. A huge thank you to our organizers who made this possible, to my fellow track hosts and speakers who worked so hard to make this conference happen. Finally, thank you all for attending the Dev Days Europe 2022 conference. Thank you so much. I hope I see you next year. Bye. I'm gonna try some deep faking as well. I have these. Can you guys rate my deep fake? Is it okay? Or
well, that looks great. Like, we do this all the time at work.
And we